audience's experiences with Java EE and how they use Java EE and so on. So I'm sure all of you work on Java and Java EE generally, but how many of you use Java EE 6, Java EE 5, J2E, type J2E 1.4 and so on? So Java EE 5, anybody here in their work? Java EE 6, people moved on to Java EE 6. Oh, wonderful. So it's already half the room. So wonderful. So Java EE 6 platform actually released about almost 3 years ago. And it's one of the most fastest accepted platform in the sense that a lot of vendors, application server vendors, immediately moved on to Java EE 6, and we already have a lot of compatible implementations already. And one of the major improvements in Java EE 6, which was widely appreciated, is not only the list of enhanced capabilities which we have brought in, but also a fundamental rethink in terms of how application servers are built. Right? So this notion of a lightweight web profile has been widely appreciated by web application developers, because we now have an alternative mode for application server vendors to start building their applications. So here are just a bunch of statistics to just show how widely Java is used. It's almost a de facto programming environment in the enterprise. Is this better? Is this better? Okay, I hope this works. So sorry about that. So 40 million downloads. We have a lot of downloads all over the world. We build the reference implementation out in the open in a project called Project GlassFish. And these are component downloads based on GlassFish as well as all the entire projects in the community around GlassFish. So that's a huge download rate. It just clearly shows how many folks are adopting the platform in one form or the other. And one of the key things which we also like to showcase is the wide support from other vendors in terms of supporting the E6 platform. So we already have around 6 to 7 vendors showing full profile as well as web profile implementations. And these include everybody from the big folks like IBM, Oracle, JBoss, to open source implementations like Kausho and Apache and so on. So it's in fact one of the fastest implementation of the Java EE release, and we're very pleased with that. So we have an evangelist called Arun Gupta, who I think some of you may know and follow. He used to maintain David Letterman style top 10. Right? So this was sort of the community's input on what they liked about the E6 platform. For example, in E6, you no more need to have a separate EJB jar. You can just bundle the EJB jar, EJB within your WAR. That was widely appreciated because now you have a single archive to deploy, a single archive to maintain and administer. Type safe DI was a big thing. CDI was one of the biggest improvements to the platform, and it's widely used. A lot of folks have moved on to CDI not only for the contextual management of their objects, stateful objects, but also for entire type safe DI. It's actually more powerful than what other proprietary frameworks provide today. The other big thing which was also an improvement in E6 was that we have increasingly moved away from the reliance on deployment descriptors. You can build an application today just using Java and annotations without any XML altogether and still have your application deployed and working. WebXML is optional. The servlet spec has moved towards annotation. So it's far more easier for a developer to get started today than it was before. I still remember the days when writing an EJB required you to write 4 Java classes and 2 deployment descriptors and so on. So this is a big improvement to those days. And we have a whole bunch of improvements. I'm not just going to go walk through each one of them. I'm sure most of you are aware of all of this, especially around extensibility in the servlet area for bringing in frameworks and also extension points by CDI to the portable extensions. So what we did in E7 was primarily take this and start to build on the momentum and see how far we can take the platform. What additional capabilities can we bring in? And one of the themes we started with about 2 years ago was that E7 was planned at addressing the cloud. See how we can enable PaaS-style deployments in Java EE implementations. So what we have realized in the last 2 years is the cloud is still an evolving paradigm. We still don't have very strong implementations, especially around PaaS, around elasticity, around provisioning, around multi-tenancy, and so on. And so it's getting very difficult to standardize those eagerly, and at the risk of things being changing. So what we have done now is revise the scope of the E7 platform primarily and moved it towards having a greater focus on simplicity and productivity and HTML5 primarily. Productivity is one of the big goals, so we want to have lesser boilerplate code. So I'll actually talk a couple of examples later where JMS tries to completely simplify the life of a JMS application developer. We are trying to add richer functionality, new capabilities like caching, new capabilities like concurrency management are all coming in as part of this E7 platform. And also we're trying to make a lot of more intelligent defaults in the system so that the application developer doesn't need to build things again and again. So for instance, today if you want to deploy a JMS application, you would need a JMS connection factory. And to just get started with a JMS application, you need your administrator to create a JMS connection factory. So we want to do away with that. We want to have some intelligent default JDBC connection pools and JDBC JMS connection factories in the application server so that it's far more easier to get started. And also rounding it off with HTML5. HTML5 is the most interesting development recently. And we have a lot of standards being developed around this area and a lot of implementations, a lot of excitement in the browsers and in the client space. So we, at least in E7, we will have support for HTML5 in the form of Websocket support, which we'll talk about in detail as we move forward. Support for JSON, processing and parsing JSON, and also support for HTML5 forms in JSF. Okay. So here is a high-level overview of the various JSRs. JSRs are Java specification requests, the means by which a technology gets standardized in the JCP process. So some of the key major specs which are going through big changes in this release are JMS, JAX-RS, and a big overhaul in the expression language support. But having said that, there are changes throughout the platform to sort of address the earlier themes I talked about, simplicity and HTML5 and productivity. So we have changes almost in every spec. I lead a spec called the connector spec, so we are also going through a maintenance release, so that's the connector 1.7 at the bottom. But we have changes happening in the servlet spec, EJB, CDI, and so on. In addition to that, what is more exciting is we have a whole slew of new functionality which is brought into the platform. So this is caching, concurrency utilities, support for batch applications, support for JSON and WebSocket. So I'll talk about most of this. This presentation is supposed to be a bird's eye view of the whole platform. So I may be eliding on a lot of details, but feel free to stop me at some time, either during the presentation or later, if you want to ask particular questions on some of the technology being discussed. Okay. So let's start with JAX-RS. So JAX-RS was brought in E6 for the first time into the E6 platform formally to make it for developers to develop RESTful web services. And it's picked up very well because it completely uses an annotation style, a very simple EOD, ease of development based approach towards building RESTful web services. And one of the constant enhancement requests we've been having in the JAX-RS space was the need for a JAX-RS client API. So almost every JAX-RS implementation like REST-EC or Jersey had their own client API. And this was clearly seen as a need which needs to be fulfilled as part of this release. So what we're working on now is to have a standard client API which you can use to invoke as well as process RESTful web services. We'll talk about an example in the next slide. In addition to that, users have also asked for ways to process incoming requests and responses to RESTful web services. Something similar to the servlet filter model. But in JAX-RS, we have a much more richer way of defining filters and handlers. And then we also have complete support for async processing, both in the server side as well as the client side. So now when we have a JAX-RS client, you can have async invocations to RESTful web services. And in the server side as well, the endpoint can process these requests asynchronously. So here's an example of the client API. So let's say today you would need to write client API without depending on any third-party application. Here's what you would normally want to do. You would create a HTTP URL connection, if people still remember that, and then have to go through all of this complicated boilerplate stuff to actually access the web service, populate path parameters, populate query parameters, and then make a buffer call and handle ton of scenarios. So what's now going to replace this is going to be a standard JAX-RS client API where you just use a client factory to create a client, and then it's just a fluent interface to populate the various parameters and resolve templates and so on. So in this example, we have a simple client which just talks to an order of web services, and then here you can see that the resolving of the template param is also Java based. You just say resolve this template order ID with this value, and automatically all the necessary URI transformations happen by the client library. You can fill in query parameters, and then it's just a call get. You invoke a get request for the RESTful web service. So this is pretty huge because we now have a standard API for working with any RESTful web service, and we've had a lot of input both from other implementations, other existing implementations like STC and Jersey, but also from the community in terms of evaluation of this API. So this API has gone through a lot of rounds of inputs that way. So the other interesting feature which is coming in JAX-RS is this notion of filters and handlers. So the filters is a way wherein you can intercept incoming requests into a RESTful web service and then work on it. So here is an example of a logging filter. Again, all of this is based on annotations, so you provide a class level annotation called ActProvider to say that it is a filter, and the JAX-RS implementation, filters container, will already make that filter available for your web service. And in this case, all you would need to do is implement a container request filter in this case, and then implement a filter method to intercept this incoming request. Okay. So this is an example of a non-wrapping call, because here you're not going to wrap the request or the response. And there are also wrapped implementation equivalents, which are called handlers, where you can actually work on the content itself and modify the content and so on. Okay. The other interesting thing, especially with the growth of multi-core processors and the growth of parallelism, is this ability to work on asynchronously on incoming requests. So here, I just wanted to showcase how easy it is for a client-side async call to be made. In this case, you still build the request like you would normally do, but at the end you just say it's an async call, and that's all is needed to make an async call to the RESTful web service. So when the web service actually responds with a response, you can actually track it using the future which is returned as part of the async call, or you can actually have an invitation callback which is also called back automatically at the end of successful when the response comes back successfully. So again, it's pretty easy today to get started with async web service invocations using the standard client API. So the reference implementation for JAX-RS has always been Jersey, and Jersey 2.0 is the implementation for the JAX-RS 2.0 spec. And this has already been integrated into the reference implementation, the Java 4.0 reference implementation, which is GlassFish. So if you want to try out all of these, you can actually download one of the promoted builds of GlassFish today and play with all of this and play with these samples and APIs. Okay, so the next spec we look at is the JMS spec. So as you would all know, JMS is one of the foundation stones for almost any enterprise application. Asynchronous messaging is at the heart of all scalable, robust applications. But if you look at the history of JMS, the last update to the spec was around 9 years ago. Okay. So 9 years ago, things were completely different. There were no generics, there were no annotations, there were no try catch block, there were no auto closable. None of these were there, and so a lot of the API was very verbose. So today, if you need to write a JMS client, it's pretty boilerplate. You need to repeat the same stuff again and again. And at least now, since we are coming to address some of these, the expert group thought that we should completely rethink the API and simplify it so that it's far more easier for a developer to work with JMS. So one of the major goals in JMS 2.0 is simplification of the API. But in addition to that, the JMS spec also wants to standardize how a provider, a vendor, a message-oriented middleware vendor provides a resource after so that it can work with any apps. Today, JMS providers may or may not provide a resource after, and so it's very difficult for someone like us to pick an arbitrary app server and pick an arbitrary JMS vendor and make them work together. So one of the goals of the JMS spec is also to standardize this so that tomorrow you can just take any JMS vendor of your choice and any app server of your choice and make them work together. So let's just walk through an example. So here is some verbose code of what used to exist, what you write today, right? So you need to write something like 13, 14 lines of boilerplate code just to send a message. Okay. So let's walk through this 13 lines of code. For example, you need to create a bunch of arbitrary intermediate objects, like connection, session, and message producer, and text message, and all that. And all of these, in a way, form the surface area of the API. And today, a JMS developer needs to know all of this, and it sets a big stumbling block for them to even get started. Similarly, there are a lot of redundant and misleading arguments. So, for example, JMS API was primarily designed, at least to start with, from a Java SE point of view, where you have complete control over transactions, you have complete control over how session acknowledgement is done, and so on. In Java EE, traditionally there is a transaction, most probably. You work in a servlet component or an agent component, there is a transaction. So usually the first argument to create session is always false. You normally never say true with it. Similarly, auto acknowledge, if it's a transacted session, acknowledgement happens automatically. You have no control over that. But you still need to specify these two things, right? And almost all of us just copy paste code from some sample because that's what the sample says. And this is really verbose code which is really not needed. Similarly, we have a lot of boilerplate code. We need to really close resources. We need to take care of closing it. We not only need to close a connection, we need to close the session, the message producer, and all that. And all of these throws checked exceptions, right? So it's extremely difficult, and you know the drill. So in addition to that, you also need to create certain app server specific resources. For example, if you want to look up a connection factory, you want to look up a destination, you would need to have all of those pre-created so that you can deploy an application. So the JMS spec wants to address all of those, and here's their proposal. So far more simpler API. It will get simpler further. Please wait for that. So here, the first thing they want to do is ensure that the connection, the JMS connection, is auto-closable, so that you can use with the new tribal resources block. So you don't need to take care of closing and so on. The close automatically is handled later, at the end of the block. And we talked about all of these intermediate objects like session, connection, and so on. So the JMS spec wants to bring both of those together and call it a JMS context. And so all you would need to do is create a context or even inject a context, and you would just need to use a context to create a producer and send it. So what was 13 lines of code has effectively become one line of code. Okay, so tomorrow in the future, since there is tighter integration between CDI and JMS, we should be able to inject a JMS context and just use the context to produce a message and send it out. Okay. So in addition to that, there have been a bunch of additional enhancements. So they've moved to runtime exceptions, so there's no more checked exceptions. There's no more creation of a payload, a text message, or something like that to actually send a text message. So all of these are radical simplifications, and it's far more easier to build JMS apps using JMS 2.0. Okay. So in addition to that, if you've been tracking Java 8.6, Java 8.6 defined a resource definition annotation called data source definition. So that today, let's say you want to build a Java EE app and you want a data source, you don't need to have the app server administrator to create a data source for you. You can just define the data source in your code, and while the code is deployed, your data source automatically gets created. Similarly, with Java 8.7, we have JMS connection factory definition, so that your single source file is your source file of truth. It has all the configuration needed, all the resources needed, definitions needed, and they'll all be automatically created. Okay, so yeah, basically 13 lines in one line. So that was JMS, right? So now let's move on to the next level of JSON. So JSON has been the lightweight data interchange format of choice today, practically for all websites. So today, if you want to look at your tweets in your timeline, you get a JSON response. You want to look at your GitHub commits, you get a JSON response. So working with JSON is almost a given, and today almost every app uses its own third-party JSON library, bundles it along with its app, and then uses it. So there was a need, obviously, for having a standard library to parse JSON. And so there is a very simple JSON processing spec which is being built, where the goal is to build both the streaming API as well as a very high-level object API. So this is very similar to the JAX model, right? We have JAX-P spec and JAX-B spec. So this is the JSON P spec, the processing spec, and JSON B spec, the binding spec, will probably come in later. So the streaming API is obviously very low level, but it's very efficient because there's no more intermediate objects created. So if you really want to know, like stacks, if you just want to know what you want to get from the JSON you've read, then you just use the streaming API and you can just directly get your stuff. But otherwise, if you want to work, like a DOM model, you want to get the whole object, you can get that using the object model as well. So let me skip some of this. So let me look at an example, right? So here is a simple JSON file, a JSON representation of an object. And here is how you would use a generator to generate this. So this is the object form of generating a JSON output. So it's pretty straightforward. It just maps exactly to the JSON spec requirements, and so it's fairly human readable and easy to digest. So you can work at the object model API level, or as I said, you can also work at the streaming level if you want your app to be more efficient. So here is an example of how you will read a JSON object using what's called the JSON reader, and the JSON reader gives you an object representation of what you just wrote back earlier. And again, all of this is configurable, so there is a provider SPI part of the spec, so that you can have other implementations actually have far more efficient implementations of these parsers and provide multiple options. Okay. So moving on, the HTML5 frame. The other important technology which we wanted to address in the eSun platform is supporting Websocket. So Websocket is an evolving standard. It's almost supported in all web browsers. It provides a way to do full duplex bidirectional communication between peers on a single TCP connection. So what we wanted to make it simpler was to address the use cases where WebSocket is used on the server, where let's say you have an app and you just want to provide a WebSocket endpoint. It should be trivial to do that. It should be far more easier to do that than work with a lot of complicated stuff like Comet, which we used to do earlier. So it's completely going to be annotation driven, and you also have an option to do interface driven points, and it completely integrates with the Java web container. So let's look at an example. So here is a hello world, WebSocket endpoint. So all you would need to do is you just write a simple Pojo and you annotate it with a WebSocket endpoint annotation, and that automatically makes it a WebSocket endpoint and provides the WebSocket URL to access it with the context specified as a value of the annotation. So somebody can now hit it at /hello, right? And any message or any frames or any data which is sent as part of that WebSocket session or connection is then sent to any method which is annotated with @WebSocket message. So let's say you have a HTML client with JavaScript, and it connects to the WebSocket and sends a string, with a name. It will just hit this, and all you can do is write Java code to return hello me, right? And so it's as simple as this. You can start building your WebSocket endpoints using annotations and interfaces. Again, I'm eliding a lot of details here because the spec actually talks far more than just creating WebSocket endpoints. It talks about how do we handle the various data types, how can we handle actually the format of the protocol between the client and the server and so on. But again, those are details, and all these specs are available in the open, so you can actually go out and check those details later if you're interested. So bean validation. We introduced bean validation in Java 6, and it's primarily a way of specifying your constraints on your object model so that it can be, you have one place to specify your constraints and be applicable throughout the entire platform. So what the latest version of bean validation does is build on those capabilities. Actually, it works with more technologies like JAX-B and also the JPA spec and the CDI spec to actually have further places where these constraint validations can be placed. So one of the interesting things which they're doing in bean validation 1.1 is what is called as method level validation. So let's look at an example. So what method validation, method parameter validation and result validation allows is basically what is called as programming by contract, right? So you say what is your preconditions for calling this method and what should the result be, and usually you will have a test suite which takes that and tests this. Right? So there have been a lot of programming languages which sort of built on this PVC paradigm. And what these method parameter annotations sort of bring in is the capability to do just that. Right? So here you have a place order method with a bunch of parameters, and those parameters have bean validation constraints placed on them. Okay? So the container will automatically ensure that when the method is called, the product name is not null and quantity is, can be max 10 and so on. And similarly, when in the next method, get appointment, you have a date which is returned, and you actually have a result validation called app future there, and that will ensure that the date which is returned is a date which is in the future. Right? So now with just this, with this code, you can actually find out the semantics associated with the method. Actually have Java doc will be based on this, so your Java doc will automatically capture the contract provided by the method. So this again, I think is going to be a huge improvement, making lives of developers far more easier. Okay, so let's move on. Now I'm going to talk about specs which are coming in new for the first time into the platform. So the first important spec which is coming in is the batch spec, batch JSR, as it's informally called. This is primarily led by IBM, and this basically allows you to build batch applications which are usually executed in offline, non-interactive, takes a long time sort of thing. So let's say you have a huge ETL job, extract, transform, load job, and you just want it to be executed in a batch mode. So there are scenarios like this, and today, if let's say somebody wants to build these scenarios in Java, they use timers, they use a whole lot of other things, and they have to actually go through a lot of trouble to actually do whatever a batch processing framework needs to do. For example, managing sequential executions or parallel executions, or actually having conditional executions. All of these are complicated logic, and today application developers do them on their own. So what the batch application JSR tries to do is sort of solve this problem by providing you a batch framework so that you can actually define your batch application, define your batch, define the various constituents of your batch, and automatically have that executed by a batch application. Okay, so let's look at an example. So here are some core concepts which are defined by the batch application JSR. So a job is the job process, the batch process, and a job consists of multiple steps. Right? So each step has what is called as a reader, processor, and a writer. A reader is where it gets its inputs for that job. A processor is the logic for that step, and then the writer is what it writes as output for the next step in the batch to consume. Okay? And a job operator is somebody who manages something or somebody who manages the batch processing. And a job repository is like a database of all jobs. Okay. So what the batch JSR tries to do is define a batch job using XML like specification language, where you can define your batch job. So here is an example of a job. It has two steps called init and process, and each step actually can say here are my reader, writers, and processors, and here is what you need to do after I'm done. Right? So for example, after init, I want to actually go on to process. Right? So they have a fairly rich way of explaining how the batch job is, and then this is used by the batch container to ensure the batch job runs. Okay. The next interesting feature which is coming in the E7 platform is a caching API. So the caching API actually has a long history. There was JSR 107 actually, which was started about 6-7 years ago, but it didn't go too far. And now we actually have a lot of people interested in bringing in the caching capabilities into the Java platform. So the caching spec is primarily for allowing an application component to save something temporarily. So for example, let's say you have a expensive operation. You want to invoke a business process which takes a long time, but whose results are valid for a period of time. So you usually want to cache them. You want to make, let's say you want to make a database call and it's expensive and you can cache those results. So this is the way caching usually comes into play. And today again, application developers write their own caching logic. Sometimes they use third-party caching frameworks like Teleport and so on, but then they are tied to those runtimes. So what the JSR defines is a standard way of defining caches, having named caches, ability to put stuff into the cache and get stuff from the cache and so on. And in addition to that, it defines a lot of complicated infrastructure like cache eviction, cache spooling, and so on. All of these are handled by the cache implementer. And so the application developer can just focus on their business logic, working with the cache, and getting stuff out of the cache. So again, this is part of the JavaX cache package and it's delivered as part of E7. But having said that, it's not tied to E7. You can still use it in SE mode. It is not a database spec. If somebody is interested, we can talk about that later, but that's the idea. So some of the key concepts in the JSR is this notion of a cache manager. A cache manager manages multiple named caches, and each cache has multiple entries, and entry is a key value. So basically, you would the SPI for bringing in a cache provider implementation is using the service provider interface, and that's how you bring in a new service provider implementation. So here is an example. So again, I think code speaks best. So the caching JSR defines certain annotations which are optional, which can be implemented by the implementer, and that will help while you build the application, right? So for example, let's say you're building a simple blog manager, a CRUD manager, right? And somebody wants to create an entry, and every time when somebody creates a blog entry, you want to put into a cache, right? So that later when somebody wants to get the blog entry, you just hit the cache first before you go to your data store. So here, if you just place the method level annotation called cache put, every time this method is called, automatically the cache key pattern, as it indicates, is a parameter for the key, the name for the key, and the value, cache value is a value for the key. So automatically entry for the title, so let's say somebody called create entry with the title foo and blog with some entry, automatically in blog manager cache, there will be an entry for foo and the value of foo, the blog entry for foo. On the other hand, now when somebody wants to do a get blog entry, all you need to do is say @cache result, and that will automatically check the blog manager cache, get the results and return it back. Okay. So again, there are a bunch of things here. You can override what is your key pattern, what is your value pattern, and so on. But the idea is the same, right? And similarly, you have methods to remove from the cache and so on. So all of this is driven by annotations. There is also an API for it if you want to use the API. But if you're just building your simple JPA CRUD app and you just want to say, cache this, it's just one annotation. Okay. So with that out of the way, so some few high-level features on some of the other specs. So JPA 2.1, again, one of the most widely used specs in the platform. So some of the key things which are being introduced in this version is schema generation. So today we actually look at your JPA entity model and then can define the schema with this spec. And also having a bulk update like delete criteria, using the criteria API. So earlier the criteria API allowed you to only work with one entity at a time. So now you can do bulk updates, bulk repeats. And you can also do stored procedure queries, so which is also something which has been asked by the community for a while. EJB. I'll skip this. A lot of folks know what was there in the EJB 3.1 platform. So what is coming in EJB 3.2 is a bunch of minor enhancements. Again, these are enhancements which are being requested by the community and by other vendors. So let's say you have a stateful session bean and you don't want to passivate it. So today you can only do that using certain proprietary, deployment descriptor is a proprietary annotation. So now we have a standard way of saying that here's a stateful bean, but don't passivate it. Just use it for stateful beans. Don't passivate. And then there are certain simplified rules for local views, local client views. So as you may remember, today you would need to explicitly indicate what your local view is, what your remote view is. So now we're trying to again default certain things so that the developer doesn't need to do things again and again. Right? So let's say you have a simple bean which implements two interfaces, foo and bar. And let's say foo and bar does not have any other annotation on them, like local or remote. And bean is a local bean. Automatically foo and bar become local client views. Okay. Similarly, let's say you have a bean, again it implements local, you have explicitly marked it as local. Since foo and bar didn't say that they were local or remote, they will automatically become local views. On the other hand, if it was marked as remote, they become remote views, obviously. But if let's say you have a bean and it implements two interfaces, foo and bar, and one of them is actually marked as remote. So then the defaulting rules sort of cannot apply because there are some interfaces here which are remote and some which are local. So in this case, foo becomes automatically a remote client view. You still have choices of making bar a local view or a client view, but remote view. But that's up to you. You would now need to actually go and do stuff. Right? So again, these are ways by which the platform automatically defaults certain things for you. So it makes the life for developer easier. Okay, Servlet 3.1. So let's talk about non-blocking I/O. I think that's more interesting. So as you may remember, in Servlet 3.0, we brought in support for async invocations, right? So you can make async request calls and so on. But once a request is coming into the server, when you process that input stream, that was still synchronous. Right? So let's say you had a do get, you would still need to go through the input stream synchronously. What the 3.1 spec proposes to do is make that asynchronous as well. So you can actually set a read listener on your input stream and have that asynchronously called back. So when this is done, so your my read listener will look something like this. This is completely done asynchronously. Okay, so it's non-blocking I/O. There's no blocking here, and so you can actually check when the input is ready and then read stuff and so on. Okay. I think I'm towards the end, so let me rush past. So the next other interesting thing within this spec is what's called the concurrency utilities JSON. So if you remember, so let's say you're writing in EJB today, you're not supposed to create a thread, right? You're not supposed to access I/O, file I/O. And usually beginners are stumbled by that. They say, why can't I create my own thread within EJB? I just want to do something asynchronously. Right? So usually these components, these managed components, do not allow you to create threads because threads are a resource which are managed by the container. And the container does a bunch of stuff along with thread management. So what the concurrency utilities JSR allows you to do now is an ability to still use concurrency, do parallel asynchronous tasks, but work within the context of the container. Okay? And it highly leverages the concurrency utility API, JSON166 API. So it's far more easier for us to move from SC to E. So here's an example. So the concurrency utility spec defines what's called as a managed executor service. It's just like a normal Java SC executor service, except that it is managed by the container. So you can use it like a normal executor service, submit tasks, submit runnable and callable objects to it. But at the end of the day, they're completely managed by the container. So for example, if you want the container to provide you transactional context or naming context to that, you can have the container do that. So again, this is looked up using the JNDI, again, like all other EE resources. So you have a managed executor service, you give it a name, then you can bind it in JNDI and then get it. So here's an example of how a servlet can use that. Right? So let's say you have a task which can take a while. So when the servlet gets called, it can just look up the executor service and then create a runnable and then submit it to that. It's as easy as that. It's as similar to Java SC as possible. So you don't need to learn a new executor API, a new concurrency utility API. Okay. So then a bunch of minor improvements. Again, they're minor in terms of changes, but I think they are significant because it brings in a lot of new capabilities into the platform. So today, certain standard infrastructural concerns or capabilities like transactions, security, and so on are all tied to component models which exist in the container. So for example, you cannot use transactions outside EJB, right? So you cannot have this container managed transaction mode outside EJB. EJBs are the only way you can create transactional components, right? Container managed transaction components. So what there's a significant move in the platform as well as in the community where they want us to, they want the platform to actually move stuff away from component containers and move them to be usable by any managed beans, any portals, any beans. So one of the cases which is being handled in this release is declarative transactions. So you can declare transactions from now on managed beans. So it doesn't need to be an EJB, container will still be able to handle it. So this is a transactional annotation bean which is defined in the JTA spec, and again the standard transaction types are supported. So in Java E7 you can have a POJO, a Java bean, a managed bean or shopping cart, and you can annotate transactions on them as transactional methods on them as transactions. And this is automatically a declarative transaction. Automatically the container will ensure that this is a transaction. And again, I think this is cool because we had EJBs which were once upon a time very heavyweight, and now it's far more simpler to use, and people still feel that they would not like to use EJBs because there's a far more greater surface area around it. So now you can just start with POJOs, declare them as transaction, and they'll still be transaction. I don't think we can get any simpler than this. So I think this is a major improvement in my opinion. Okay, JSF. So JSF 2.2 is again a significant, is a big improvement because they're actually addressing a lot of big ticket items. So two big ticket items I want to highlight here is HTML5 friendly markup support. So HTML5 defines certain data type and attributes, right, which are useful from the JavaScript in the website, but not to the JSF component. So they've now defined a generic way to pass through attributes like these, and also define what is called as faces flows. So people have used Spring Flow or even ADF flow. We know that usually a complex web application defines a flow of various screens, right? And today when you want to define something like that, it's extremely complicated in JSF. You have to hand code this flow and manage transitions between these various screens and so on. So what JSF plans to do is sort of make it easier by defining what is called as faces flows, define flow scope annotation so that you can define flow scope state and then use it across it. Okay. So CDI. So CDI has grown out to be one of the interesting developments in E6, and it's widely appreciated by the community for type-safe dependency injection. What CDI 1.1 wants to do is define how CDI can be used outside the EE container. How can we have an embedded mode so that you can start your own CDI runtime in Java SE so that you can do some testing. Right? So that's something which is interesting. In addition to that, today, interceptors and decorators which are brought in CDI 1.0 are defined on a per bean archive level. Right? And usually, let's say there are multiple bean archives in your enterprise application. You would want to define globally what the ordering is. So these are enhancements which are coming in CDI 1.1. Okay, so that was a quick rundown. So what I wanted to highlight here was that the E7 platform has been making a lot of improvements. And a lot of these improvements are being driven by the community, by folks like us. Right? So we participate in various expert groups, we participate in discussions, we send our feedback based on our experience with past specs, and share our enhancement requests. Usually a spec is driven by what is called as a reference implementation, and the reference implementation for Java EE is Project GlassFish. And Project GlassFish is an open source project, so all these specs are not just built somewhere in a room elsewhere. Right? They are built in the open. You have the spec built in the open. You have the reference implementation built in the open as well. So you can try out all of these bleeding edge features today. You can just go to glassfish.org, check out the 4.0 downloads, and you can play with them, give feedback, ask questions, and so on, leave comments. So that was what Java E7 was all about. E8 and beyond. Right? So what can we do? So we've already been getting a lot of inputs from expert expert group members and the community and what we should do. So here are some high-level goals. Again, these are goals. Things will change as we move forward. So one is deliver on the cloud work which we started in E7. In E7 we started work around multi-tenancy, started work around PaaS. We couldn't get to a great extent on that. Right? We couldn't make a lot of headway on that. So in SE8 we want to define that. We want to clearly define multi-tenancy, especially in containers like JPA and so on, where it's far more easier for SaaS applications to build SaaS applications to leverage multi-tenancy. And then, since Java 8 will be based on Java SE8, if Jigsaw comes in, we have a modularity story. So I think that will be very exciting when we have that. So here's a bunch of resources. Again, I will actually highlight it in the next slide. All these specs are transparent in the sense that all the work in these specs happen in a publicly available alias and a website. So we have a Java.NET project for the Java spec. Java spec is the platform spec. And all the individual specs also have their own Java.NET projects. So if let's say your interest is only Websocket, so you can actually go to the Websocket Java.NET project and participate in the Websocket case. The reference implementation is GlassFish, and we actually keep a blog role in Aquarium. And one interesting thing I wanted to point out, which is a recent development, is what is called as Adopt a JSON. So this was actually a grassroots based initiative. So I think it was a London the Java user group in London, which said, all these JSONs are there, a lot of experts actually participate. But community members also do participate, but they don't get to participate on a standard way. Right? So one of the ideas was, let's actually talk to these various JSR spec leads, seek out what are the help they actually need, and then have the community participate. So you can actually, if let's say you're a community, you have your own jug, or you have your own individual club which is interested in participating, you can actually go there, pick a JSR of your choice. There are some standard startup level class tasks which you can get started with, and it can be anything from giving feedback to giving comments and documents. Right? So that's an interesting place if you're interested in the JSR project. So again, as I said, all of this is available, transparent. So all these specs, you can actually see them as they are built. So we have expert group mail archives, we have issue trackers to track issues, we have download areas for the specs in transition, so we can look at them, communicate, participate. So rough status. So all JSRs are up, all are running. We almost have early drafts, public drafts available on them. The final release is somewhere around Q2 next year. So hopefully we'll see this being used by all of us by Q2. Anyway, let's skip this. So with that, I think I'm almost out of time. I have 3-4-5 minutes for Q&A. Yeah, please.
So why this 7, Java is 7, kept on delaying like since last 1 year it was going to be released, right? Last 1 year back.
Yeah.
Waited, but somehow, because is it only because of this cloud party has separated from that, or something like that? I don't know. It's too late, but
yeah,
it's too late. The other frameworks have come with similar things much earlier to Java 7.
Yeah. So normally various platform specs, it takes 2 to 3 years of incubation. The platform spec has usually taken 2 to 3 years. Every spec E5 to E6 was 2 years. E6 to E7 I think is now
6 came in 1 year only. Java 5 to 6 it was a very early transition.
It was 1.5 years.
1.5 years max.
Yeah. Anyway, these specs take a while because it's not only it's not just a number. 6 to 7. Right? Actually, 7 brings in a lot of new capabilities, so that actually brings in a bunch of delay. In addition to that, as you rightly pointed out, cloud was also one of the things which the expert group was moving towards, but then actually delivering on the promise will take a longer time, so they had to repurpose, rescope and so on. That's why we have it. And again, I think this is better than what it could have been. Like, let's say we actually want to deliver a true cloud PaaS multi-tenant spec. I think it would have taken 2 more years, which I think would have been very good. So I think what we have today is.
Along with GlassFish, are they going to be incorporated in WebLogic also?
Yes. So GlassFish is a reference limitation. It's an open source reference limitation. WebLogic is the Oracle's container of choice. So WebLogic also will have a corresponding lease and releases. So
One more point I wanted to ask, maybe slightly out of context.
sure.
Java in GlassFish earlier versions, right? They had this JBI in them, Java
Right.
Business Integration.
Right.
They were removed afterwards.
Right.
Although they work wonderfully, we had some projects also, but
Okay.
removed. Now we are solely depending upon Oracle Server Suite. There is nothing else. So is that is going to be some kind of alternative for that, because only using Oracle it is restriction?
Right. So JBI,
Yeah.
if you recall, is a standard technology defined through a JSON. But it was not part of the platform.
But what is the future of that?
Yeah, so there is still OpenESB, I think is still there. That's a
OpenESB is not working now.
Yeah,
They have
so-
closed their shops.
Okay.
Right now, I think Oracle has closed their shops. Purposefully, they have deleted every link for OpenASP just to support SOA.
Right.
Oracle SOA Suite.
No, but I think JBI as a technology itself, I think people have moved beyond JBI.